So welcome back. This evening we're going to work on multiplying and dividing, work with equations. As was said earlier, multiplying and dividing are what we call inverse operations. So again, there's this backwards thinking. So thinking backwards is very powerful as a problem-solving strategy for problems that we may not be able to work out in our head. This gives us a strategy to work it out on paper. Another point to make out, we said multiplication is commutative. Division is not commutative. Order does matter with division. For instance, 10 divided by 2 is not the same thing as 2 divided by 10. So notice that these do not give me the same answer. So it matters a lot where the numbers are in a division problem. Notice that 10 divided by 2 would give me 5. 2 divided by 10 is the same thing as 2/10. And 5 does not equal 2/10. So that's not a true statement. So you cannot change the order of a division problem like you can a multiplication problem. With that said, a couple of things we want to bring into mind is a division statement. So if I say 30 divided by 5 is 6, what has to be true though is if I go backwards, 6 times 5 has to get me back to 30. 6 times 5 would have to equal 30. So for a division statement to work, that multiplication piece has to also hold true. Don't forget when we did 6 divided by 0 earlier on, we said this is undefined. Because remember, 6 divided by 0, if you put 0 there, did 0 times 0 get me back to 6? And we discovered that's not true. So we said, well, 6 divided by 0 must equal 6. But we discovered, though, that 6 times 0 gave me 6. That wasn't true. So we learned also about this property when we talked about division by 0 as being undefined. So when I do this problem, though, notice that 30 divided by 5 is 6. I can check it because 6 times 5 doesn't give me 30. That has to hold true for the division problem to play out. So when I give you this division problem of 45 divided by 9, notice how that equals 5. I can also make a multiplication statement that says 5 times 9 is 45. That statement has to also be true. So for every division statement, there has to be a true multiplication statement to go along with that. So anytime you see a multiplication problem, there's a division problem to go with it, or vice versa. If there's a division problem, there's a multiplication problem to go along with it. So let's use that thinking to go with solving for x. So what number divided by 5 is 7? What I can do is, instead of thinking this is division, I could work backwards and multiply to get that to hold true. Because if x divided by 5 is 7, then 7 times 5 has to equal x. So x would have to equal 35. And if we look at that, 35 divided by 5 would give us our 7. Looking at another example, I have x divided by 6 is 4. So if x divided by 6 is 4, what I can also say is 4 times 6 has to get me back to x. So 4 times 6 has to equal x. So that means 24 is equal to x. And if I look at this, 24 divided by 6 does give me 4, so that does play out correctly. So notice how, again, even though I have a division problem, I can solve it by thinking backwards and use multiplication as my strategy to find what x is. So if I'm looking for what number divided by 8, let's go over here to this problem, number 3. What number divided by 11 is 9? If I can't see that, what I can do, though, is go backwards and multiply. And that will tell me what the answer is. So I can use multiplication as a strategy. 9 times 11 should get me back to what x is. So 99 is the value of x. So x would have to equal 99. Because 99 divided by 11 does indeed give me my 9. That makes it a true statement. Now back to 4. What number divided by 8 is 7? We should see that, hey, that answer is, well, whatever 7 times 8 is. 7 times 8 is 56. So backwards thinking can solve that problem for us. Okay? So again, when we see division, don't forget we can also think backwards and use multiplication to find that answer. Stay tuned.